Bismillah. So we will continue our lesson in chapter 5. Just to refresh, we have in chapter 5 we deal with rigid body, equilibrium of rigid body. So basically the steps are to draw free body diagram and also solving using equation of equilibrium. We have covered 2D and also 3D. And for drawing the free body diagram, we have covered several things. One is support reactions of many different type of supports, and also we have covered also on two force member. Right? Those things will affect how you draw your free body diagram. Right? And currently we are in the part where we deal with 3D structures. And we have covered several examples already, so this will be another example. So in this question, we have the uniform plate has a weight of 500 kilonewton, supported by 3 cables, as shown there. So we need to find the tension in each of the supporting cables. So in this question, we need to find what is the tension here, here, and here, right? So as usual, the first step will be to draw the free body diagram. So in this case, the axis is like that. So we have the plate here, something like that. Right. Okay, so we'll have something like that, and we'll have the tension here. Tension here. Have force going down here. Right. Let's see, this is FB. Let's see, 200 kilonewton. Right. Anything missing? Yeah, in this question the weight is given, so you have to consider that one. So where is the location of the weight? So yeah, it should be at the center, so somewhere there, somewhere there. So if that is the center, so we'll have this point going down 500, and we need also the dimensions of 3 meter, 2 meter, 2 meter, 2 meter, 1.5 meter. Alright, so that is the free body diagram. Any questions so far on the establishment of the free body diagram? No question, right? Now, how to solve this one? How many unknown do we have? 3. How many equations do we have? How many equations? What are the equations? Summation of F equal to 0 then summation F equal to 0 then. Any other equation? Dia cakap ni mulut ke tak? Tak ada baik. Tu tak wedding ke? Any other equation? Tak ada? Ya betul ni, kita belajar chapter ni. Summation of moment what? X we have covered several example before, right? This one it should be like dah muak tengok lah sebabnya. Sebab tu yang malas nak sebut lah. Should be you already should be very familiar with this one, right? So we have 6 equation and 3 unknown, right? Can we solve? But of course, in this particular question, when you have so little unknown, you will notice that some of the equation is not useful. For example, if you do summation of f equal to 0, what you will have? You have 0 equal to 0, right? So, tak apalah macam tu kan. Summation of f is also the same, right? Because there's no y component at all, right? So, if you do this one, it's just 0 equal to 0. That's my answer. Tak salah. And another one is this one, moment about z. Right, because there's no force that is rotating about z-axis. So basically, effectively, you will have 3 useful equations for 3 unknown, right? Alright, so which one will you use first? Fz. So if you do summation of Fz equal to 0, what do you have? Fa plus Fe plus Fc minus 200 minus 500 0. You cannot solve it, right? Next question. Summation moment about x equal to 0. What do you have? So you're talking moment about this axis. Fa, does it produce any moment? Clockwise or counterclockwise? Counterclockwise. So you take the convention of using the x as positive at thumb, so counterclockwise is positive. So you have Fa, distance of 3. Fp, does it produce any moment?
No.
Fc? Yes. Clockwise, counterclockwise? So positive. Fc, distance of 3. The 200 Newton. Clockwise, counterclockwise? Minus 200, distance of
3.
the 500? Minus 500, distance of
1.5.
1.5. Right. So still 2 unknown, you cannot solve yet. Then summation of my equal to 0. So got this axis here. Fa, no moment. Fb, clockwise or counter? Alright, so negative. Fb, distance of 4. Fc, positive or negative? Negative. Fc, distance of 200, positive or negative? Positive 200, distance of 2, and then positive 500, distance of 2. Right? So can you solve this one? So in the end, how many equations? So we have 1, 2, 3 equations, and then you have Fa, Fp, Fc. You can use simultaneous equation to solve. And then mathematics. Any question? Okay, no problem. Simple. Now, this is one way to do it. Okay, basically we have scalar and vector. So you can use both. Not both, meaning you can choose either. Right? And we'll try to show what is the implication. Right? But for scalar also, you have several options. This is one option that is most traditional. Right? And you can solve. I think hopefully you can solve simultaneous equation. Right? But for me personally, I do not like to do like this. Right? Why? Kenapa? Sebab malas. Normally orang malas ni dia malas nak buat simultaneous equation. Right? Those lazy people do not like to do simultaneous equation. So what I tend to do is, I introduce this as my x prime. The intention is so that this one becomes 0, this one becomes 0, I can solve that one. Right? So if you notice, if I do like this, summation of mx prime equal to 0. Of course, I have to draw this to be able to do this one. Right? In the exam, right? What will happen? Fa, no moment. Fb, clockwise or counterclockwise? So minus Fb, distance 3. And then Fc, no moment, 200 no moment, and then 500 is plus 500, 1.5 to 0, right?
Yes.
So can you solve Fb? Can solve straight away, right? Similarly, I say, okay, I want this to be my y prime. So summation of my prime equal to 0. So I have Fa positive 4. Fc no. 200 is corresponding minus 200 distance of 2 minus 500 distance of 2 to 0. Fa straight I solve, and then when I do summation of Fz, I can solve for Fc. Right? So that's another way. Right? We have covered last week, I think, not last week, last class, where this axis can be x, meaning any parallel of x axis, right? You remember that one. Similarly, y, z. So this is an example of how it can be applied like this. Okay, so of course this is just to show an option, right? It's not compulsory to do this one. Ini untuk orang malas je. Yang rajin buat macam biasa. So it's up to you what you want to do, because the answer you can try and post, and the answer should be the same. The only difference is the length of ni lah. Kalau sayang pokok-pokok kat hutan tu. Alright, so any question? Okay, now this is if you use scalar. And question like this, it's very easy to use scalar, as you can see, because everything is vertical like this. If you have angle, alpha, beta, gamma, etc., then normally it will not be as easy like this. And it might be easier to use vector. Right? So just for example, let's try to use vector. So if you use vector, basically you only have two equations. Summation of f equal to 0, summation of m equal to 0. Meaning the original equation is just 2, but later on you will still have ijk, which goes back to this one. But how you establish this one is more okay, we'll see. Now summation of f is just simply add everything, right? So just summation of f. So I don't think I need to show that one. It will be just f a k plus fbk plus fck minus 200k minus 500k, right? So in the end you'll just get z component anyway, right? But for summation of m is basically, you can say, summation of r cross f, right? Now if let's say I consider this is my origin and I put everything there, meaning r cross f from this point, eventually I'll get from this axis, and this axis. Right. So let's try that one. So summation of m, or summation of r cross f, is for fa. If I do straight away in the matrix, the r will be what? From here to here. So 0, 3, 0, 0x, 3, y, 0, right? And then here is 0, 0, FA, right? For FB, I, J, K, it will be 4, 0, 0, 0, 0, F, D, right? And plus K. For FC, X is 4, 3, 0, 0, 0, I, J, K. For the 200, X is 0, minus 200. For the 500, 2, 0, minus 100, right? So basically this is what you do if you use vector. Obviously it will be longer than scalar for this question, right? Because you include everything, x, y, z, x, y, z, x, y, z. So if we just solve this one, so in this case for I you'll have 3fa. For j you don't have anything, for k you don't have anything. For this one, for I you don't have anything. For j you have minus j. For f e. Why is it minus? Okay, this, if you do not write everything, you should make sure you get it right, because if you write everything, then I minus j plus k, I minus j plus k, right? But if you don't write, make sure you are aware of positive and negative then. This one for I, 3fc. For j, minus j. For fc, you know. This one for I, minus 600. For minus j, minus 400k, no? For I here, minus 750, right? Is it? Yeah. And minus j minus 1000. Right. Now, if you group everything, you'll get for I you'll have 3fe plus 3fc minus 600 minus 750. This one is I plus for j you have minus 4b minus 4fc plus 400 plus 1000 j equals 0. Everything equal to 0 right now, right? So in the end, you'll get back this equation x and y, right? And if you check with the first solution that we do, it should be the same. The difference is, in this case, all the positive and negative comes straight away from this one. When we do manually, you have to assign positive and negative by imaging the clockwise, counterclockwise, right? Again, for this particular question, this seems like much more difficult than doing just using scalar, right? But again, I'm just showing this one because just in case if you have any angle like that, then here is easier because you just change this thing, right? And then automatically the value goes there. But if you use scalar, then you have to resolve and you have to imagine everything. For some students, it's still easy. For some students, they get confused, right? So make sure you know which one is better for you for the exam, right? So you should try both and see which one works best. So in the slide, basically they use the first solution that we show, which is basically the scalar equation there. And if you just check, is it the same here? Should check 3TA, 3FA here, 3TC or 3FC here, minus 750 minus, it would be exactly the same as this one, right? Why? Because we take just now moment about this point, which effectively becomes this is the axis and that is the axis, right? So it's related to that. Yep. Any question? Do you follow? Of course, I'm not showing the simultaneous equation part because that's mathematics, and you should, practice on that. So I'm just showing the until the statics part because, and then using blah blah blah, you get those answers. All right. Any question? Is it clear? Of course, in question like this specific question, because everything, if you notice, everything is positive. So if you get negative any of the answer, it should be wrong, right? Why? Do you understand why? Okay. Yeah, because the question is all the tension is in the cable, right? There's no possibility of that becomes negative. All right. Concept quiz. So here we have the rod and it's supported by these two cable here, one cable and two cable. This is separate different cable here, and then we have ball and socket up there. So in total, how many unknown support action? How many are here? What are the unknown? XY, AX and Y. Yang mana lagi? Agree, disagree? Tak nak kecil ganti, tak nak disagree. Ball and socket. So you have AX and AY. Is that ada tak? Ada juga. So AX, AY kan? Dah berubah jawapan. Okay, do you understand what do you have for ball and socket? Right, you cannot move in any of the directions, right? So make sure you understand this one because buatkan saya risau kan. So how many have here? One. How many have here? One. Tension saja, right? So in total, if you get this 5 force, right? There's no moment there. Okay, this question should take only 5 seconds, right? Okay, 1, 2, 3, 4, 5. Macam tu je lah. So if you think too much about this one, it give a warning signal about the final lah. Seperti menung. Sepatutnya terus boleh lukis. Alright, so we'll skip this one. Yang tadi pun gila, malah nak tahu itu nanti lama. Alright, so we'll take a look at this example here. So a bend rod is supported by both journal bearing at A, B and C. F is 800 Newton. Assume the rod is properly aligned. Find the reaction at all the support. So basically this F is already given as 800 Newton. And another point is about the properly aligned. We discussed this in the last class, right? Where I mentioned that in the exam we tried to avoid this type of question, but you have to understand that. But this is on the slide, so we have to discuss it anyway. Yeah. So if you draw the first step is free body diagram. So if you have X here, Y, Z there, right? So if we have what is like that, and then here going up, right, something like that. So A, B, C, right? So what are the forces that we have? Of course, the given here is after draw this one. So this is based on the two triangles, there and then going down, right? So this is one force which is F equal to 800 Newton. So this is given as 30 degrees. This is 60 degrees, right? All right. What else? What do you have here at point A? X, Y, Z. AX, AY, Z. So do you have AX? AY, do you have AY? This one? Yes. Is that? Now, any objection? Now, how determine whether you have AY or not? Yeah, that depends on the name, right? So if you have, do we call truss bearing and general bearing, right? So for general bearing, do you have AY or not? No. AY. Why? Because it does not restrict that movement, right? You can actually free to move that one, right? Do you have moment? MAX, do you have or not? MAX. Yes or no? Yes. MAY? MAY? No. MAZ? Okay. If you recall, originally it should be like this, right? But we also discussed on this part here. When it is properly aligned, this one will be, we can just neglect this one because it will be equal to 0. Right? Because if you consider like this and it will happen on the other two general bearing also, you have too many unknown that you cannot solve. So that's why the question will give you, okay, this is properly aligned, so this one you can just consider that one. So this is only when the question gives something like that. Right. So in the exam, do not meaning the other two should be there if it's not the case of properly lined. Okay. So similarly will be happening here. Oops. Point B. So what do you have here at point B? No. You have BX? No. BY? BZ? And C. Do you have CX? CY? CZ? So in that you have something like that. 3 unknown, no, 1, 2, 3, 4, 5, 6. 6 unknown, 6 equation you should be able to solve. So of course the dimensions should be also 2 meter, 1 meter, 0.75 meter, 2 meter. Alright. Any question on the free body diagram? Okay. Hopefully you understand because what we discussed about the properly aligned, right? Okay. So how to solve? Do you think you want to use vector or scalar? Tak ada apa tak nak solve, tak nak. Vector. Okay, if you say vector, I'll solve with vector. And if you have vector, then you have two equations basically, summation of forces equal to 0 and summation of moment equal to 0. For summation of force, so what will you have? You have summation of forces equal to 0. So basically you have AXI plus AZK plus BYJ plus BZK plus CXI plus CYJ. And then for this 800, what is the X component? 800 cos 60 cos 30 I. And for J plus 800 cos 60 sin 30 J. For Z should be minus, right? It's going down 800 sin 60 K. Right. Any question here? Of course, this goes back to chapter 2, right? Hopefully by now you are very familiar with that one. What about moment? So if I take moment about this one here, moment about the origin of this frequency diagram, summation of moment about O equal to 0. Do you know about it, Karim? Okay. So it's basically it's basically summation of all R cross F, right? So if we take first for A1 first, for A1 for R cross A, so from this origin, so it will be what? If we took I, G, K, R will be -2, 0. And you'll have AX 0 is that right? Meaning you consider both as one component. Right? For P, of course this one doesn't have anything because it goes to the 0, so A2 is just 0, 0, 0, right? Now and then plus I, J, K. For B you have X is -1, 0, 0, 0, BY Z plus for C I D K X is minus 1.75 0 2 CX Y, right? There's nothing like that. If you want to put in writing, that one is become normally we just omit this one, right? But just to put in perspective, it will be 0 0 0 because that, right? And here is basically this 800 cos 60 cos 30, 800 cos 60 sin 30 minus 800 sin 60, right? This one equal to 0. Now, normally we do just don't write this one, but I have a reason why I write this one here, just for next discussion. So anyway, if you do this, should we try this? Okay, we'll try. So here when we do for this one, I will get minus 2az j 0 k plus k minus minus kan, jadi plus 2ax kan. Betul kan?
Yeah.
Betul. This one for I 0 for z j, so minus j minus vz kan. For k plus k minus 1. For this one for I plus I minus 2cy j minus j minus 2cx plus k minus 1.75 cy. Kan? Because this will be 0 0 0. Then equal to 0. So if you notice here, how many equations do you have? Because you can, meaning you can put this in terms of the, if you cluster this x, y, z, right? Meaning for x, you have here 8x plus cx plus this one equal to 0, right? For y, you have this one, and this one equal to 0. And for z, you have this one, and this one equal to 0. So this question is quite interesting because the simultaneous equation, there's no exact same match that you can solve straight away, right? And you're stuck there because you have how many unknown? 1, 2, 3, 4, 5, 6, right? Here also for I, you'll have this is I, this is I, right? You have z, az, and cy. So it doesn't match. For y, you have negative this one and this one for z. So you'll end up with 6 equations and 6 unknown. So pandai-pandai lah. Right, because then I'm not sure. You have to try. That one is mathematics. Right, so I don't want to waste my time with mathematics in the class only, because that one is just using the time to solve, right? Is there any better way? Now, I'm not sure if this will help or not, but okay, one possible way, okay, just like what we discussed in scalar, for example, if we select different axes, it can reduce the number of unknown, right? Similarly, if I say, okay, this one will give, this one you cannot run away because forces you have 6 unknown, because all x, y, z, that's the case. But moment you can change where the point is, right? If I say, no, I don't want about this one, I want to do about this point here. Let's say moment about point A now. Right, moment about point A. What will change? Now, in this case, this one will be 0, right? So what will change here? This one will be 0 because it's there, right? And then for B here, what will happen? Y becomes
minus 2.
Is it minus? Okay, this one, because we draw the axis here, that will make it confusing. Right? Because if you have this point here, R will be like this, and no, R will be like this, right? So Y will be positive, right?
Okay.
If you want to choose this one, then it might be easy you draw the axis there. That will avoid the confusion of negative and positive. But if you understand the concept, is from here to here to here, then it's positive, and this one is negative, this one is positive, right? So it will become 2. What about C? Basically, this will become 2, right? You just add this one here from here, right? And this one? 2 here, right? So you'll notice that if you do this, the number of unknown will be less because this one will not be in the equation, because this one will be just 0. Then you have dy dz, cx cy, and then the number here in equation, right? So I'm not sure whether it helped in terms of the actual calculation. So you can try in the how to solve the simultaneous equation, right? But in the statics part, then this is how you establish the equations before you solve. Any question? So in the exam, you cannot run from mathematics lah, because part of the question, actually the longer time you actually have to spend on the simultaneous equation for this question. Okay, any question? So please do try masa cuti or masa sambut Deepavali ni. Alright, so okay, this one is the part of the 100. So in this case, if you see the slides, it used the dia guna axis mana? So it used axis. Apa dah tahu x ni? X. Apa x? X is 2. Y is 2. Yeah, okay. In this case, it actually, if you notice, the origin is brought to here also, right? You know, this the drawing here, x is there, y is there, z is there, right? So that's why you can see in this mx, it doesn't have this ax and this one. It just have this component here, right? But of course, in the exam, you don't have the chance to suddenly become the answer like this, right? You have to show. So please do try and solve that. Okay, any questions on that one? Alright. Attention please, okay. Let's see how many seconds you take for the one. So a plate is supported by a ball and socket joint at A. So ball and socket here. A roller joint at B hilang ni. Roller joint at B and cable at C there. How many unknown support action oh dia tutup ni, ada benda hilang ni. How many support action are there in this problem? Alright. In total. Kalau dia tak tengok, dia boleh jawab. How many is here? Apa dia? What ada? Yes, and Y, Z. How many here? Ni roller. Okay, tak tahu. You understand roller? Tak faham. Oh, dia tak tahu roller. Aku tak boleh jawab. Tahu ke tak tahu? So this is right? It's basically just like you have a ball bearing under one, right? Or roller, the different type of roller is like this, right? And then how many here? So in total? Ini dicampur kan? 3? 3 plus 1 plus 1 is 5. Okay, soalan macam ni susah jawab. Saya letak soalan exam macam ni dulu. Alright. Okay, this one is a bit more how to solve this one, right? So what will be the easiest way to determine the force? This is the same exact, this one. Okay, if you want to draw this one will become AX, AY, Z, say BZ, say tension C, for example. So the question say what will be the easiest way to solve for BZ? Which one? Moment about what? Why? Because if you take moment about this point, about the axis, basically every of this it will actually go through the axis. So you need to calculate moment, summation of moment about y. This is the only unknown that you have, right? This and this. Yeah, so that's normally the strategy. Where you have many forces, you just take moment about that point, so it cancels all the powers, right? So that's what we normally do. David. Alright, so we have finished with this part. Just to check, so we have finished chapter 5. Next is chapter 9. And then chapter 10. And then chapter 6. So why is it like this? Because dia nak bagi harapan palsu, nak ke lah? Belum. No, actually, there's for whatever reason in this chapter, some of the questions you can only answer if you understand this one, because it will use something here. So that's why in this course we rearrange it in that way. So we will go into chapter 9 right now. Alright, so this is chapter 9. Alright. Now we will be dealing with center of gravity, center of mass, and centroid. Are you familiar with those words? Kita tak pernah dengar. Center semua pernah dengar kan? Gravity, pernah dengar. Mass, pernah dengar. Centroid? Ya betul, centroid tak pernah. Exhibition?
Force distribution tengah center.
Force distribution. Okay. But now I think in normal real conversation in real life, I think the most famous is center of gravity. I think. For example, if you talk about vehicle, sometimes you know about center of gravity. So in this part, the objectives is for you to be able to understand the concept of center of gravity, center of mass, and centroid. And not only that, we need to know how to locate the location. Alright, so an example of real engineering world, if you have to design this tank, for example, normally there's two things, right? One is, if I want to design the support here for it to be safe, one is I want to know the weight of the water inside, so the support should be able to support the weight. And to calculate the weight is just, if you know the density of water, you know the volume, you can calculate. But in statics, another thing that we have learned so far is if you want to draw the free body diagram to calculate for moment, etc. One thing is that you have to know where to draw the weight. Right? And in our exam, sometimes we have something like this. For example, we have shape like this and G is given, right? But as an engineer, you cannot expect this. You have to go to the field, mana G mana? You cannot find, you cannot see, right? So you have to be able to calculate on your own where is this location. So this is what we have to learn. Okay? Kalau you tanya macam ni, mana G tak nampak pun, memang memalukan you aja lah. Alright. So you have to know how to locate that one. So that's another thing. Okay, this one is more, maybe a bit more familiar as well. Biasanya tak ada orang cerita-cerita nak design tank. Yeah. So SUV, sport utility vehicle, one concern is when it's speeding and it wants to take a sharp turn, for example, right? So what is the possibility to yeah. Apa relation dia? Okay, normally we discuss in terms of it is more stable when, okay, is it higher or lower center of gravity or center of mass?
Lower.
How do you know that?
It will not move past the contact point.
How do you know that? Huh? For example, I think the more I'm not sure right now, but I think this for those who like to watch F1, for example, right, there will be many discussion about the lower center of gravity, right, etc. Right? Why? Okay, my question is why is lower center of gravity is better? Is lower center of gravity better? Why? Stable. How do you know that lower center of gravity is more stable? Why? How come? I mean, you say center of gravity lower is more stable. Why? Because normally we apply, we just okay, that's why we want center. But this is the fundamental question. Why? I mean, who says that? Kenapa you beriman je? No question. Why? Any explanation or you just accept whatever? Siapa yang cakap tak? Oh, tak tahu tak? So why do you accept that as a fact? Is it logical? Oh, logic macam mana? How is your logic? How is it logic when you say lower center of gravity more stable? Memang orang painting kan lagi stable. Macam mana? Apa? Buat kajian, saya buat kajian tu. Now, another application, I think, have you seen the double decker bus? Not the London one, but I think here also there's many like long bus you have. If you following the double decker bus on the highway, for example, you will see that the shape is like that, right? It's quite tall. Have you seen? Have you ever wondered if it's actually go to the side road here, right? Or side road here? Will it topple? Will it topple over? Does it seem possible? Do you feel safe to ride on this? Oh, tak pernah naik? Kau tak naik bas?
Tak naik.
Siapa yang pernah naik? You dah atas ke bawah? Saya takut jatuh, saya duduk bawah lah. Now, so, but have you ever heard any news of the jatuh? Because what? Malaysia road is very flat. No worry. What? So, why doesn't it topple? So this is relating to the center of gravity. Okay. What? Okay. If we have this. Okay. If I draw it to more extreme here, right? If we consider tak ada tayar lah, macam nak senang lukis kan, like that, right? Will it ever? Do you think that it will actually topple? Oh tak? Nampak macam nak jatuh tu. Nampak ke tak? Tak, saya tak biasa tengok dia tak jatuh. Now, visually we will assume it will topple, right? Why? Okay, based on experience, any object that we put is most likely that. Why is it topple? Because if we consider this is center of gravity and this is weight, about this point will produce moment, right?
Yes.
This moment is what topple it over, right? If somehow we can design the center of gravity here, the force is here. What is the rotation? What is the moment? The moment is counterclockwise, isn't it?
Yes.
So it's quite interesting that even though it's like this, you want to go here. Because the moment is like this. Meaning the tendency is to go this way, not that way.
Yes.
Aku tak boleh terima, tak masuk akal. Yeah, so this is what we learn on the moment, right? Meaning if the tendency is to go that way, obviously it will go that way, right? But in this case, we are talking about this point, but about this point, then it's like this, right? So it's cancelled, this one, right? But in this case, this will rotate this way. About this point, it will rotate this way also, then it will definitely go that way, right? So this is where we design it so that this one center of gravity is very low. So that's if it's very low, it takes very high degree for it to topple, right? Because the center of gravity is still here. It's still not going that way. It's still going this way, right? Now the same concept. If because so jangan risau boleh naik. Kecuali designer dia silap design memang dia jatuh lah. But how to get this? Normally because the weight, maximum weight is here. Right. So another one, I think that is more close to home, for example, for those who have lah. Anyone who have the thing that you punch, it go down and go back up? Ada? Pernah tengok? Aku tak tahu. Bukan yang keras yang tak, yang macam lembek yang jatuh naik balik. Ada? Dia bukan adik you yang tumpuk dia naik balik. Itu lain. So why does it like this one? If you punch it going to the ground, it will come back up. Why? Because the weight is basically the weight. Every weight is here. Right? This water here is air. So if you can imagine the moment will be like that, right? So that's why it can come back up. If you puncture it and the water goes down here, then it will never go up lah. So this is the concept that we have learned about moment, etc. That we maybe without realizing it, it's many applications that we can see, right? So this is where the concept is important, and what we will be learning is how to actually locate where is actually it at. That's what we will do, right? How to design to make it lower, etc. That will be not first year subject, it will be later, right? But in this subject, we are just going to learn where is it, right? And of course, I'm showing that case because that's more closer to statics. This one, if you talk about cornering, that's already dynamic, right? So you have a momentum, etc. So that's more complex there. Okay. There are many other applications. For example, like this, we want to know where is the location so that we can design properly. Tapi I don't think any of you play this sport. So ada ke? Ada. Berarti ada kan? Kita tak tahu ni apa benda ni. So, alright. Now the concept. So basically, any object that we can refer to, any object, basically you can consider this as to be consisting of particles, and each particle will have its own weight. Right, that's the idea. And now, this relates to what we have learned in chapter 4, basically, right? If an object, and to simplify, normally it's that thousands or millions of particles, right? But if you can just consider it's made of several elements like this. Each of these elements have its own weight, right? And the equivalent is, if we have learned in chapter 4, if you have multiple force, what we have learned is something like this, right? If we have multiple force, we can get one force and one equivalent moment. And or it can simplify this one and the location, right? So it's the same idea. This one have its own. This one, the equivalent is the total, the summation of all the weight. The location can be calculated by the same concept here. Meaning because this moment and this moment with this one should be equal to the summation of moment of everything here, like what we have done in chapter 4. Right? So that's how. You understand this idea? So when we go to the equation that will be shown, it will be similar to this one, right? In this case, if let's say this is f, right? F, and let's say f1, 2, 3, 4, and then this one is d1, d2, d3, d4, the distance. So here the moment, summation of moment is summation of fd, right? Which is f1 d1 plus f2 d2, blah blah blah. Okay, and that's summation of moment here should be the same as fr. Let's say this is dr, right? Or x. So fr and dr should equal to this one. So if you want to find what is dr, is basically summation of moment equal to summation of force, because fr is actually summation of force, right? So it becomes something like this: summation of moment and summation of force. Summation is basically you just add individually here. Summation of force is you add all the force. So with that idea, we can relate to the actual equation just that will come here, right? Right. So in this case, right, this is the okay. You will notice several things here. One is you have this kind of x, and you have the normal x. Do you know the difference? Anyone learn about this? What is the equation of x? Panggil apa? Ni x. X bar ke? Panggil really? X apa? Tak pernah ke? Anyone learn this one before? X. Nak panggil apa tu satu hal? X apa ni? Ni x ni? Ha? Theta? This one? X bar. Kalau sebagai X bar, you boleh bayang ni. So, saya dulu macam masa kecil saya bayang ni X. Tak ada apa-apa tak kepala dia. Ni dah pakai topi Congo tu. Ni Donald Trump ni rambut. So nak panggil apa? X Trump, X Congo. Tapi kata bar, kalau bar tak boleh Congo lah. Anyway, so so nak panggil apa? Tu kata tak nak panggil. Tak apa, X bar, X wave ke apa boleh? Tak tahu. I'm not sure what is the actual name. Nak tulis tu tak tahu, nak cakap tu tak tahu. X yang ni pening pula. Ni pening. Alright, so now what's the difference? Okay, if we go to the semua marker nak pilih. If we go to any xy plot, right? If you have curve here, let's say the curve, any general point, right? Point this one I can draw here, here. We can say the coordinate is x, y coordinate. Right? What it means is, meaning this length is x, this length is y. That is what it means. But when you see like this, it's general. If I say I draw here is x, y lah. The meaning is it's a general point on the curve. Now, if you want to calculate the area under the graph, for example, right? The area under the graph. How you do in terms of integration is basically you chop off into million of element. Have you done this? And basically you can consider one of the element, to have its own center is x, y wave here. That's for the element. Right? And if you add everything and then you calculate the center of the whole area, you'll have x bar, y bar. Okay. So this one, it refers to the whole area. The bar here. So meaning in this case, it refers to the final distance, the final location. This for element, meaning for each individual force, each element. This one is just general because in terms of equation y equal to mx plus c, this is general yx. It can be anywhere like that. Understood? When we integrate etc., we integrate the general. That's why we want to know how it relates to, because this one is specific value is this element. This one is also for the whole thing, right? So going back to here. This is the final distance, this is the total force of weight, this is summation of each individual distance line force. If we use the word force here, right? Why is it W? Because weight, gravity we deal with weight, right? So in the end you will have this equation here. Right, if you rearrange, you get this one, right? So you'll have x integration of x bar, this is x with dw over integration of dw. Right. This is center of gravity. So gravity will deal with weight. If we say center of mass, we deal with mass. So we just change the dm. Dm atau dm? Siapa selalu? Center of, okay, like center of, okay, another one is centroid. Yeah, centroid is basically center of shape, either area or volume, right? So if you consider area, so x equal to integration of x dA integration of dA. So you understand the trend, right? Meaning if we talk about gravity, each of the force is weight lah. If we talk about mass, it's mass. If we talk about area, it's area. If we talk about volume, it's volume. But the concept goes back. Why is this equation like this? Is the concept of moment here. And if y, then y, z, z. If you memorize 1, you can memorize. It's just replacing y and z. Okay. Now, for answering the exam, you can just memorize. But I do think it helpful if you at least understand any moment in it, because in later chapter 10, etc., you have a different set of equation of integration also. And then some people, if they forgot, they can mix the thing up, because it seems similar but it's different. So if you do not know what is what, then because here logically is the distance between the force, meaning if you understand the concept of simplification there, you can understand why is it like this. And why is chapter 10 later is different. Okay, any questions so far? So I think the next slide is actually showing that one. So if it's mass, then center of gravity with respect to weight, center of mass with respect to mass, etc. So you can have W, V, A, L, etc. L is if you have a line, but normally in our syllabus we skip that totally because that is more confusing. Normally we can imagine area easily, right? If you have shape, area, but if you have line, then it's a bit tricky to explain to everyone. Volume also sometimes most of the time we skip for this one because to integrate for volume is more difficult because it's 3D. Normally we integrate just 2D, line 2D, right? So, alright. Any question? Okay, now concept of centroid. So again, centroid is basically shape of area of volume. Basically, now if you understand shape, okay, if you consider the bus, right? This is a bus, right? Centroid just refer to the shape. Meaning, this shape, the center is here. This is centroid, right? But center of gravity or center of mass, it depends on what is the weight of the component. So for the bus, the maximum this is very high density, or the weight is higher. This one is weight is low, for example. So that's why the center of gravity is low, right? So the point can be at different point. Meaning, center of gravity and center of mass, is it the same or different? The same, because mass and weight is directly related with gravity, right? It can only different if we are a different planet, gravity delay. But on Earth it's the same, right? But this one is different, right? Because this one consider the shape, this one consider what actually is the material, for example, right? So we have discussed this before, right? I think in chapter 4, when we do some example of if it's a rectangular, it's there. If it's a triangle, we get 1/3 of the length, 2/3 of the length, etc. So the calculation here based on moment will result in the centroid. So it's like this. And if you have the textbook, you have a lot of table like this at the end cover. Right? It will show this is 1/3 here. You can see 1/3 of H, etc. So later on we'll go about on that one, because you have to be able to refer to the table. In case of the exam, we'll give you the table and okay. This one. Okay, what is the difference of this one? This one is the line, because in the table you will have also shape, the same shape but have color like that. That means it's area, right? So normally in this subject we skip line because can be confusing there. Okay. Centroid coincide with center of mass or center of gravity if the material is homogeneous, meaning if the density is the same, obviously the center of gravity will be the same as centroid, right? Like we saw in the past. Okay. So what else? Okay, if this is just tips, right? If it's symmetry, then obviously it's on the symmetry line. If rectangular is symmetry here, obviously it's there, right? But if you have like this one, is it symmetry? Kata tak sama tak. Kalau similar ni, is symmetry here, right? So C is on this line, but whether it's here, here, you have to measure, right? And here it says, in some cases, the centroid may not be on the object. For example, if your object is like this, let's say, center of gravity is here, meaning it's not actually on the object, but right. So that's also possible. Right. So I think we will proceed further after this, because to get into the calculation, I think better, because into calculation this is where we have more fun. We have equation, we have integration, right? So cuti dulu lah. So tahu dah ramai tak siapa nak integrate. But of course, again, in this subject like this, you have the engineering concept and theory, and you have the mathematical part. So you cannot excel in the engineering subject without the mathematical part, because at a certain point you have to integrate, you have to do simultaneous equation, etc. Right? So make sure you polish on that. And if you have any, I don't know, if you already have reboot your brain to forget about integration, make sure you recall that back, because when we go into the subject, we will assume you know how to integrate. You just apply. So if you lost that, it will be very, very hard to catch up. Okay, so before we end, but some of kids, I think you will notice some of your friends came to the class because they say they have a different class, and then suddenly that class cancel, or they suddenly come. So extra you can return it back. Otherwise, you collect your paper. And with that, we end the session. Subhanallahumma bihamdik. Asyhadu an la ilaha illa anta astaghfiruka wa atubu ilaik. Assalamualaikum warahmatullahi wabarakatuh.